Greetings, mathematicians. Welcome to this narrated PowerPoint on trigonometry. Solving right-angled triangles. So, the first question you might be asking yourselves when it comes to solving right-angled triangles is, what on earth does it mean to solve a right-angled triangle? Well, it's simple. All that it means is that we have to work out the size of all the missing angles and determine the lengths of all the missing sides. And to do that, we use trig, amongst other things. So let's look at our little example here. Solve the following right-angled triangle. There it is, a right-angled triangle. B is our right angle. I couldn't find the little right angle symbol when I made this, but let's just pretend that there's one there. B is our right angle. We are given angle C, which is 34 degrees, and we are given the length of the hypotenuse, which is 12 centimeters. So in order to solve this right-angled triangle, we'll need to determine the length of AB. We'll also need to determine the length of BC, and we'll need to determine the size of angle A, and then we will know the lengths of all the sides and the sizes of all the angles. So what are we going to start with? Let's start by determining the length of AB. How are we going to do that? Answer: trigonometry. Look at angle C. That's the angle we're given. This side here, side AC, is the hypotenuse. The side that we are looking for, AB, is the side that is opposite to angle C. So we think to ourselves, which trig ratio uses opposite and hypotenuse? The answer is sine. Sine is the ratio of the opposite to the hypotenuse. So we state our little ratio here. The sine of 34 degrees, the sine of this angle here, will be equal to the opposite divided by the hypotenuse. Now we fill in the values that we know. We don't know how long the opposite side is, because that's side AB that we're looking for, but we do know that the hypotenuse is 12 centimeters long. We now have a little equation which we can solve. I'm going to take this 12 here, which is dividing on the right, and take it over to the left where it will be multiplying. And then I just enter all that into my calculator, 12 times the sine of 34, and I get to the size of AB. There we go. The little red box of glory tells us that that is the answer. Now, you might have tried that on your calculator, pressed all the right buttons, and got a completely different answer. The reason is because your calculator is in the wrong mode. What I want you to do is look at the top of your calculator and check, does it say degrees? Your calculator might just say DEG, dig. Does it say degrees, or does it say rad or grad? If it says rad or grad, it is in the wrong mode, in which case you'll need to press the DRG button to put it in its correct mode, so that you can get the correct answer. So check your calculator now. Check it now. Do it. Do it now. Get to the chopper. Where did that come from? Who even knows? Moving steadily along. Right, so we've worked out the length of AB. Now we need to work out the length of BC. And BC is the side that is adjacent to the angle that we are given. So which trig ratio uses adjacent and hypotenuse? It is, of course, cos. So we state our ratio. The cos of this angle will be equal to the adjacent side divided by the hypotenuse. Then we fill in what we know. We know that the hypotenuse is 12 centimeters long. We don't know how long the adjacent side is. That's the one we're trying to figure out. But we now have our equation. Let's take the 12 over to the left where it timeses, press all the buttons on our calculator, and huzzah! We find out that the length of BC is 9,95 centimeters long. How wonderful. So now we know the length of AB, we know the length of BC. All that we have left to figure out is the size of angle A, and because this is a triangle, and all the angles of a triangle add up to 180 degrees, and we know that this is 34 and we know that this is 90, we can use basic grade 8 geometry to figure out that angle A is 56 degrees. There it is. Triangle solved. Right, so on to the next one. Example 2. Solve this right-angled triangle. There it is. There's another right-angled triangle. You will notice that we are not given either of these two angles. We obviously know that B is the right angle, but we don't know how big A is. We don't know how big C is. So we've got to calculate the sizes of those two angles, and we have to work out the length of BC. I'm going to start with that, because to work out the length of BC, we can just use basic Pythagoras. Grade 8 maths at its best. This is a right angle triangle, so Pythagoras will work. There it is. Because BC is not the hypotenuse, BC squared is going to be equal to the hypotenuse squared minus the other side squared. And that gives us the length of BC, 9,79 centimeters. That was easy. Now we have to work out the size of angle A. So if we look at angle A and look at the sides that we are given, what are these sides? What position do they have relative to angle A? Well, this is the hypotenuse here, and this side AB is adjacent to angle A. So we think to ourselves, which trig ratio uses adjacent and hypotenuse? Silly old hens cackle and hackle till old age. It is cos. Yes. So we state our cos ratio that the cos of angle A will be equal to the adjacent divided by the hypotenuse. Then we fill in what we know. We know that the adjacent is 7. We know that the hypotenuse is 12 centimeters long. We have an equation which we can solve on our calculator. We press second function cos, then 7 over 12 equals 54,31 degrees. That is the size of angle A. And now that we have angle A, we can use basic grade 8 geometry to work out the size of angle C, because of course all three angles of a triangle are supplementary. And there is our answer, ladies and gentlemen. C is 35,69 degrees in magnitude. Well, that wasn't too bad, was it? Okay, bye-bye.